And welcome everyone to today's data science seminar series. I think this is number 4 for us here at the University of Chicago. Today we're joined by Professor Ali, who is prepared to take us under the hood of some of these generative AI models. It's funny because the last two, I don't know if Professor Ali knows this, but the last two data science seminar series were on generative AI, because that's the hot commodity right now. So it's kind of very timely to say, okay, it's the hot commodity, but how do these models actually work? How could they break? What kind of goes, how does the magic work, so to speak? So Professor Ali, I will let you take it away. But before that, again, one final reminder, for those of you that just joined, feel free, turn on your cameras. We like to make this session interactive, though I'm sure there'll be time for Q&A. So if you're able, but with that, I'm going to go ahead and hand it over to Professor Ali to take it away for Data Science Seminar Series number 4.
Thank you, Daniel. All right, so we have a few people here. Can you just type where are you joining from, your location? So let's see in the chat if you guys can join, type there. Okay, Chicago, Georgia. Okay, Chicago. Houston, okay. Kuwait, Mexico, Korea. Wow, Uzbekistan, North Carolina. Wow, China, Canada. Wow. So people are joining from all over the world. Thank you so much for joining. London, Bangkok. Okay, all right. So I am going to share my screen now. Thank you so much. All right, well, let's see. I am going to go off camera for the presentation, but you can stay on. Okay, so like Daniel said, today we are going to see what is actually the secret when it comes to these AI models, what goes into the machines. This is me. I live in Chicago. I have worked in data for almost 20 years across the continents, lived and worked in many countries. I've built many data warehouses or data solutions from ground up. I've been teaching for last 7-8 years now. I've been teaching data engineering, and I also advise final capstones in the graduate program. I'm also co-founder of a very exciting startup with my friends from Harvard, and that is focused on human capital using generative AI. Like Daniel said, it is the hot topic of the town. So when we speak of AI, this is not something new. AI has been around for a very long time, at least theoretically, from the 40s and 50s. And very recently, with the advancements in technology and our access to more compute, has enabled us to actually convert that theory into practice. So AI has been in practice for a few years now. It's not just ChatGPT came along and everybody wants to use AI. I've been working with customers for the last 4 or 5 years, and they've been using artificial intelligence. So when it comes to artificial intelligence, everybody thinks that, okay, Terminator is coming, it's going to destroy everybody. This is the end of times. I don't think that is true. At least in my opinion, I am somebody who believes on the positive side of artificial intelligence. I feel AI is going to actually make lives better. It is going to increase our productivity, increase our efficiency, and create time for us that we can spend with our families and friends and do things that we want to do. So AI is basically not going to destroy. AI is going to actually enhance our lifestyle, because every time a technology is invented, be it a car or a plane, anything that is invented has made our life easier. Okay, so that is me. There are people who believe AI can destroy, and if it is in wrong hands, it certainly can. So when it comes to AI, in my experience over the past few years, I have worked with several customers who have used AI for automation of several activities, including robotics. For example, if they want to scan packages and send it, or if they want to scan items on the shelves, you may have seen them, in some fancy stores. If you go there, there are bots running around the aisles and scanning the items, and their accuracy is higher than human beings. Now, I'm not saying they are removing human beings or replacing human beings, but what they are doing is they are making a monotonous activity easier for us so we don't have to do it. And because they don't get tired, so they can just do it. Then there are many machines around the house. I have Roomba. Roomba is basically a vacuum cleaner, it's a robotic vacuum cleaner. Then I have a Bissell. Bissell also is a automatic mop. It cleans the floor so I can do my job. I don't have to clean my floor, basically. So that is a good thing, right? Then text analytics is very common. In the age of social media, everybody is expressing their opinions. If it is about the products or companies or certain people, politics, they just go online and they express their opinions. So it is very important for organizations to understand those sentiments. So text analytics is another part that is basically artificial intelligence. Then you can create recommendations or you can predict forecasting, for example, and financial planning is another thing that can be done through artificial intelligence. You can identify, if you guys go online, most of us use online, you see that it shows, okay, this is the item that was bought by another person, and this is the item you should purchase because you bought these two items. All of that is some kind of artificial intelligence because the word is artificial. Intelligence is, of course, there, but that is all it is, automation of monotonous activities. Natural language processing is very common. We are using it every day. Alexa, everybody uses. Siri, everybody uses. Google Home, everybody uses. We talk to them, they have become part of our life. And the more we talk to these machines, the more they understand us and the more they can be useful to us. If you use, let's say, Netflix, or if you use any other, Amazon, for example, and if you do not rate your products every time you make a purchase, the bot in the backend cannot make a good recommendation because it does not understand you. It can create some patterns based on your purchase history, but if you provide more information, it will know more about you and it can make better recommendation. So at the end of the day, basically AI machines are here to complement us, make it easier for us. Computer vision is becoming very popular these days. It's very common, with the drones, for example. And if you want to take images and then convert them to text, that is also very common. With Sora, which is now coming out, is actually creating videos. But at the end of the day, in the backend, it is using computer vision. All these videos in the backend that it is using to train, all these images that it is using to train, to generate new content is all based on computer vision. Then there are GI systems which can be used if there is a disaster somewhere, a natural disaster, or if there is some crime they want to detect. All of these are examples of artificial intelligence. Neural networks are very common for deep learning. When you think about deep learning, it is basically, you think about these large language models or you think about generative AI and you think about reinforcement learning, all it's doing is that it's learning from the data that it is gathering, storing, and analyzing, and then it's feeding back to the machine so the machine can actually learn from its own experience. So I'm going to the next slide. So if we think about the trends, what has been happening last couple of years, a lot has happened. So if we think in 1 year, so much can happen. Imagine what can happen in next few years. So OpenAI released ChatGPT 2 like a couple years ago, not even a couple years ago, 1.5 years ago. Then they released 3, then 4. And then everybody was like, oh, this is the end of the world. Artificial general intelligence is coming. Terminator is coming. It's going to kill everybody. Or if nothing else, white collar jobs would be gone. Even then, people were using it all the time. Everybody was using ChatGPT on their phones, online. It started a new trend, a new way of doing your search online. More and more people started going to ChatGPT versus going to Google. It was, of course, affecting their business, and it was a new way of interacting with the machine. People enjoyed the conversational nature. So what happened? Google said, well, we can also release Bard. Let's do that. Which was, of course, everybody knows what happened to that. And then Gemini. Microsoft said, well, let's just invest $10 billion in OpenAI and we can just start working with them. And now Microsoft is walking away from them and they have hired Yusuf because they say we will build our own Copilot. Perplexity is another company that has raised about $600 million in last 1 year because they claim that we are going to change the search forever. And all they are doing is, again, using generative AI to basically bring content from all over and provide the references. So the race is going on. Everybody wants to be in the AI. So these were the big boys. But now every other company, they want to have their bots too. Why not? Everybody wants to play with ChatGPT. Everybody wants to have something on their website. And it's not like these bots are new. I mean, it's been around for I mean, I remember I've been talking to these, online when you go, when they have the help icon, you click on them and you start talking to it. And they've been around for a very long time, but now they have become more human-like. It looks like you're talking to a person. But at the end of the day, it is a machine, and you can tell that. But conversational AI is becoming basically the norm. People don't like static responses. That's why more people want to use bots on their business websites because they want people to have a conversational experience. So now, again, every time a new technology comes in, people start thinking because fear drives many things, and then people say, hey, now conversational AI is going to finish all the professions where it requires talking to people, for example, therapy or sales or teaching. Any professions where people need to speak with people will be dead. Nvidia is benefiting a lot because what they have created these GPUs that people were using to play games, and now everybody wants AI. So what? Everybody wants those chips. Because of that, Nvidia is going, making lots and lots of money. To the extent I saw that a few days ago, Microsoft now released their own AI PC. I was like, what is AI PC? So they have a NPU, not a CPU. Basically, the idea is that these machines will come with built-in chips that will make AI processing possible. And one is wondering, why is that happening? You know why? Because Copilot is basically AI, it's a large language model, and Microsoft have actually integrated in the Copilot in every single software. It's in Microsoft Office, it's in their, browser, it's in Windows, everywhere. So now they have created these softwares, but they don't have the underlying hardware to run it. So now what do? They release a new PC with the more powerful chip, and they're calling it AI PC. It's not like the PC is going to start walking like a Terminator. The only thing is that, it has a new kind of chip, which is more powerful and can compute large language models so that Copilot can actually work. So much is going on in the last couple of years. You know what? People are getting tired of all this, confusion and, changes. Everybody wants to learn all these new technologies and they start learning today. By tomorrow, something else comes up. They're like, what is going on? Everything is moving very, very fast and all at once. And what is happening because of all these new, advancements or inventions? The more data is required, more companies are coming out. They are building their foundational model for everything now because they say, hey, you know what? I will create a foundational model for this thing, or I'll create a foundation model for that thing, because eventually it will become like an operating system. Nowadays, we have on our computers, we have an operating system. So then we'll have another layer on top of that, which will be basically this foundational model. So first you have the hardware, then you have the operating system, and then you have the foundation models. And it will be required. And that's why many companies are popping up every day. Startups, they are building their foundational models. So foundational models require a lot of data. You need to train these models. They are not going to learn on their own. Like I just gave an example when it comes to Amazon or when it comes to Netflix. If you don't rate your movie, if you don't rate your purchase, the bot is not going to learn much about you. But these powerful machines require a lot of data, like trillions and trillions and trillions of rows. For example, if we speak about Bard, it is trained on all the data that is available on the internet. That is a lot of data, right? Still, it makes mistakes. ChatGPT took years to train their model, and then they released it to the world. Everybody was using it. They thought it was a toy, but in reality, that was basically testing. They wanted all of us to use it so that the more we use it, the more it will learn how to become better, which is a good thing. It's not a bad thing, but that is what happens. So now all this data that we need, it does not exist. Majority of the data does not exist. And we have these foundational models. So how do we train them? So now there is a new trend coming up, synthetic data. Well, you don't have data, that's okay, we can create data. But if you create data, is it going to be correct? How credible it is going to be? What about the bias? See what happened to Gemini a couple of weeks ago. That is literally a very real life example what bias means. Somebody or a team intentionally, they had good intentions, tried to add some controls to these model trainings. And guess what happened? It is creating stuff which is completely made up. And it is offending people, even though the intentions were good. So that is one challenge with synthetic data. So you can create synthetic data, but you have to be very careful the data you create is not biased. Okay. So many companies are still actually utilizing the data that is available. Like I gave example of, for example, Bard or ChatGPT. I was talking to one of the customers the other day. They are using Wikipedia. They have imported entire Wikipedia to train their model. Now, Wikipedia is publicly available, is free, right? And then again, social media, for example, if it is Instagram or Facebook or Twitter, X, for example, you can actually purchase the data. Now, of course, in certain cases, data has been not used properly, but the data is available on the internet. You can get access to the data, for example, for sentiment analysis, and you can utilize it to improve your product or improve your business. Why is that important? Because there are about 8 billion people who are, at least as of, I think a few months ago, there were 8 billion people in the world. 5.4 billion of these people use cell phones. Isn't it amazing? Not everybody uses a computer. And 5.1 billion of these users are online all the time. And guess what? 4.7 of them are active on social media. Wow, so many people active at any point on the internet. What do? They generate a lot of data. Look at this. They are using WhatsApp, they are using Facebook, they are using Zoom, Instagram, YouTube, you name it. They are using anything and everything online. All of this data that is generated, all of this data is not useful. That is where you need to be very careful when it comes to bias or when it comes to credibility of the data. You need to identify what data you should use to train these models. Because if you just dump all the data into these machines, it is just garbage in is garbage out. You can have a Lamborghini, but if you don't put good oil in it, the Lamborghini will not be able to do anything. It will be actually destroyed. So you can create all these fancy models, but if you don't have the appropriate data, these models will not be useful. They cannot do anything. So what are these people doing? Majority of them are using messengers. They're messaging each other or families or friends or for work. They could be using WhatsApp or WeChat, and there are so many other messengers. Facebook has a messenger, right? Or they are on the social network. 94% people are basically spending time online, communicating and connecting. That's a powerful thing. And then 81% are actually doing search. Imagine 81% people moving from Google to ChatGPT. That is a big loss. A lot of people are shopping too, 76%. Well, I should give them my address. Maybe they can send me some gifts. So it's just amazing that, so many people are online all the time, billions of people. So all this data is going somewhere, but that is just the tip of the iceberg. What is happening to this data, right? So now all this data is just like a flood. It's like a tsunami. So you can either run away from it, right? Lots of data. How do I manage it? Or you can actually ride the wave. Like many people are doing it now. Many companies out there are utilizing the data and they're benefiting from it. So how do you do that? Well, everybody talks about data science and artificial intelligence, but many people don't know there's another thing in the back end called data engineering, which is actually enabling all these models to do what they are supposed to do. So if you think about data engineering now, it's not new. Data engineering has been around for a very long time. But if you look at all these trends, every day something is coming in artificial intelligence. But data engineering is the same. It's not changing. It's still the constant. The only thing that is changing, of course, is the technologies. If there's a new technology for data engineering, you'll use that. But data engineering is the same. The principles are the same. People don't realize that, there's no artificial intelligence without information architecture. It's a very popular thing. There's no AI without IA. So you can build all these fancy models, like I said, but if you don't have the data or if you don't have the infrastructure or the process in place, your model is just sitting there and doing nothing. So the data that goes into these systems has to go through a very comprehensive process. The process of cleaning, the process of connecting, transforming, and then finally loading into the final destination. The destination can be a data lake, it can be a data warehouse, or just external systems, but it goes through a very long process. In reality, if you think about these AI systems, 80–90% of the work is actually in the backend, the data engineering. That's why some people now call it like artificial intelligence engineering or machine learning engineering. But at the end of the day, it is creating these pipelines, connecting them, bringing data from all these multiple sources, combining them using different rules, and then making them useful for the analyst or the AI engineer or the business user. The data engineers are actually a lot in demand these days, and it will continue with time because more and more companies are adopting artificial intelligence. Like we just discussed a few minutes ago, everybody wants to be in the race. So for that, they will need all these data engineers who can actually build these systems, automate the data processing system and the pipelines, and then maintain these systems. So if you want to acquire a skill, in my opinion, become a data engineer, okay, before ChatGPT replaces you. So the technologies will come and go. That is how the nature of a technology is. In my experience, 2 to 3 years is the life of a technology. Maybe 5 years is pushing it. If they do not innovate more, the technology is dead. So many technologies that I was using 15, 20 years ago, they are not around. Actually, the technologies that were very popular at a time are not around anymore because technology changes with time, the needs change, the requirement change, the data volume changes. So these organizations have to continuously innovate or improve their technology. If not, a new technology will replace them. So I am going to the next slide and my slides are stuck. So data engineering is just like real life engineering. If you look at this picture, there are a lot of pictures there. We have the dam and the stadium and the building and a very complex road structure and a bridge. So all it is showing is that, these are beautiful infrastructure. When you look at them, they are beautiful, but it took years and years to build them. A lot of planning, thousands of people to build these things. But do you even know them? Nobody knows them because they're in the back end. That is how data engineering is. So many people, so many people work together to build these systems, but because they're in the back end, nobody knows how much effort goes into that. So next time when you work with analytics team or engineers, maybe tell them thank you, because without them, these beautiful infrastructure you see are not possible. So when it comes to basically the flow of knowledge or data, the data is at the foundational level. And as you go up the pyramid, your value is increasing. With the data, you have more information. And once you have more information, you gain knowledge. And once you have more knowledge, you can make wise decisions. And as you go up the pyramid, the value increases. But without the data, there is no information, there is no knowledge, there is no wisdom. So that's why data engineering, again, for data is the bloodline for every AI machine. So this is just one other pyramid of data science, or you can call it artificial intelligence or whatever you call it, but it's the hierarchy of needs. Again, at the bottom, as you see, we are collecting a lot of data. It can come from internal systems, it can come from external systems, depending on your use case. If you're using IoTs, for example, Internet of things, it could be a lot of sensors, or even airline, it could be a lot of sensors. Or in your home, we just talked about Roombas and Bissels, they all have a lot of sensors. So all of that data, either a software engineer can help you with that. Why we are saying a software engineer? Because these are the people who can write software code for you, or they can write preprocessors for you that will gather this data. Then from there, a data engineer picks up, or group of data engineers will pick up the data, and then they can then create all these pipelines. The data comes in many, many forms. It could be structured like a tabular form, or it could be completely unstructured, like a graph, or maybe like a log, or an email, or a website. All of these things are unstructured data types. And the process for moving the data from one location to another location, and then cleaning it, preparing it for the final destination, is done by data engineers. And then, of course, data scientists come in and they're doing all kinds of fancy work, analyzing data. They are doing data mining. They are also supporting the training of the data models, right? And then once you have all of this, you can then do your deep learning, your artificial intelligence. So going back to the point at the bottom, again, is data. Without data engineers, or in this case, software engineers too, there is no artificial intelligence. So that was all about, like artificial intelligence, machines, data, and everything, but how the sausage is made, people want to know, right? So, well, the process is called extract, transform, and load. And now it has a fancy name, data engineers. So basically, you have data from all these different sources. You are extracting it. You can extract it directly if you have access, or maybe the external sources will send data to your area or your landing area. We can call it the pull or the push, pulling the data from the sources, or they are pushing the data into our landing area. So once you have extracted all this data, you actually load it into an area called a staging area. And in that staging area, you first look at it, analyze it, understand it. If there are anything missing or incomplete or incorrect, you do not fix them. You report back to the source systems and tell them, hey, can you please fix this? The reason you're not fixing it is because if you fix it now in your area, it will come back again in the future from the sources, and you don't want that because you want it fixed. So that's why it's not a good idea to fix data in your environment. And then once you have applied all these transformation rules, for example, the business user tells you that, how do you calculate the lifetime value of a customer? They tell you, well, we look at the purchase history of a customer over the past, 3 months or 6 months. And then we forecast and assume that customer is going to be with us for 5 years or 10 years or 15 or 20, whatever lifetime they expect the customer to be there. That is how they calculate the lifetime value. So you take that logic and you build it. And when you apply that logic, you actually transform the data from sources into this logic. And then you can load the data into your data warehouse, or you can load into data lake, or you can just send it to another source that is waiting for you. You can, make it available to business users if they want to use any business intelligence tools, for example, Tableau or Looker, or there are tons and tons of technologies out there. You can use R or you can use Python to analyze this data. So that is what you can do. But before it reaches the final destination, it goes through all this process. You have to create all these pipelines. use APIs, connect them. There's a lot that goes into it. For example, your source system may not have data, or the source system may delay the data, or you may not have access rights to the source data. So all these things, combining all these things and running the entire process end to end is very important. And it has to be done in full automation, because you cannot just sit there and look at the process. How long does it take? Because some processes can take a few hours, some processes can take a few days. So I was working on one of the project where we were calculating actually there were two projects. One project was propensity to default. So I was working with a bank where we were actually checking if a certain person will have the higher propensity to default. It's like calculating the risk, right? Should we give them the credit card or not? If we give them the credit card, then how much should be the credit limit? $100, maybe 1,000, or $1 million, depending on their credit score, depending on their history from other sources. We were calculating it, but before we were calculating it, we had to bring all this data from all these different sources, combine it, and then run the model on it. The other case was we were actually calculating out of stock analysis. So we were working with a very large manufacturer, and their goal was to identify out of stock items. So now what is out of stock items or out of stock analysis is, if you are a retail store, or even if you are e-commerce store, let's say if you're Amazon, and somebody comes to your store and you don't have that item. For example, I walk into your store and I wanted to buy stuff for my breakfast. I wanted bread, I wanted eggs and milk and butter. And as soon as I walk into the store, I go to the bread aisle and the bread is not there that I like. So it is highly likely I will leave. I will not go and get the eggs and the milk and the butter. I was like, you know what, let's just go to another store. And if I do that, it is likely I may not come back. So that is why we can say that's the opportunity, lost opportunity, because the customer could have taken some share of my wallet, not the customer, sorry, the retailer, but because there was no item that I wanted, or even a few of the items were not available. So because of that, they lost my revenue. Now, that was just one person. It could be hundreds of people or thousands of people. So that's why it's very important for these companies to do the out of stock analysis. So for that, they need historical data. So I remember we were running the model and we were using 1 year of data, and that model was running for 14 days. It would run for 14 nights actually, just to predict 1 week out of stock. And that's all, just 1 week. So we'll run the model for 14 days. It will run overnight with thousands of virtual machines. And then after 14 days, we'll get an output for 1 week out of stock analysis. Now you may say, well, you spent 2 weeks and you only got 1 week of out of stock. But that analysis saved this company millions of dollars, because they realized if something is out of stock, they could actually restock it, so that when I walk into the store, I don't just leave without buying anything. And there are many, many similar examples when it comes to out of stock analysis, because they can scan your shelves and then you can see, okay, what item sells the most or what item does not sell. You can move them. The position on the shelf, every position has a different value in terms of money. Every aisle has a different value. And sometimes you may think that, okay, when you walk into a store, certain things are at the cashier and certain things are all the way at the back of the store. And why is that? Because one, when you are waiting on the line to check out, you will look at these things, these gums and maybe candies. And because you're standing there and getting bored, so you will buy them. That is how they increase their sale. And certain things are all the way at the back of the store. You know why? Because when you walk into the store, you will go all the way to the end, and as you're walking, you may see things that they have nicely put on shelves at a certain eye position. So you see them and you buy them. Costco actually does that intentionally. Costco moves around their stuff and they make it into a maze. That is their exact business model. So if you go to the same Costco again and again, you will realize certain items keep moving from one location to another, because they want you to walk around the aisles and explore. So that is how all of these models are only enabled because of the data that is coming from the stores and the purchase history. So at the end of the day, again, everything is data. How these pipelines are maintained and created, that is very important. If you don't have them, your models are not going to work. So when it comes to data engineering, there is a lot of technologies out there. I just found this one online and I thought I'll share this one, but there's so much, so much. So if you see on this one, this is a very, very high level. As you can see, you can have data warehouses. Nowadays, Databricks and Snowflake are very, very common. And then you have the Amazon Redshift is basically from AWS, and then you have Google BigQuery. Then you have, if you can run your processes in a batch, you use different technologies, or if your load is real time and it's a constant stream of data, then you use different technologies. So what's the difference between a batch and a stream? A batch is, for example, when I was explaining this out of stock analysis example, or if you were to do some analysis on the weekly sales or monthly sales, so you don't have to collect data every second of the day. You can just collect the data, weekly data or daily data, and then keep storing it and then process it as a batch. Because certain things do not require real-time analysis. Airline, yes, that will require airline will require real-time analysis. Or for example, the bot that is running in my apartment requires, real-time analysis. But a retail store, I don't think so. It can wait for a day or two or for a week. So that is what a batch is. A stream, if you are talking about, let's say, fraud detection, then of course that has to be real time. It has happened to me many times that, I was using my credit card in a different city, and as I'm checking out, they will just block my credit card. And I'll get the same second, I'll get a call from a human being, not even from a machine. And I'm like, why? They say, well, your card is being used, let's say, in California. I say, well, because I'm here. They say, well, but we did not know that because all your purchase history is in Chicago. I was like, well, that does make sense, right? So again, they could tell because of the data, because most of my data was from Chicago. So they could say, well, why this card is being used in California? Why now? Why today? Right? So that's what happens. Now you have a lot of batches, you can have streams, you can have, all these new technologies you can see on your screen, and they're just coming up every day. There's a new technology. But at the end of the day, the principles are the same. You are bringing data, combining it either as a batch or loading it as a stream, processing it, and then bringing it all the way to the AI systems. I wanted to show this diagram because we want to learn every technology that comes out. This diagram is a couple years old, I think from 2000. Yeah, it's from last year, 23. But can you see there are like thousands of technologies out there? You cannot learn all of them. You should not learn all of them. If anything, you should just focus on the foundations, learn the principles, and technology is just a means to an end. So I wanted to make sure that you understand that every day there's a new cool technology out there. Don't jump at it. Just focus on the principles. Learn the principles. And yes, if your job requires you to learn that technology, or if your school requires you to learn that technology, sure, by all means. But just because everybody is talking about a technology, you don't have to learn it. Only if you need it. Because there are so many technologies out there. And you have to see, not everything is a hammer and not everything is a nail. You need different tools for different kind of use cases. Depending on your use case, you will need a different kind of technology. So that brings me to the end of my session. I just wanted to leave you guys with this one nice Spider-Man that with great power comes with great responsibility. And why am I showing that is because it's not just as a user. When you're using these technologies, you have to be very careful. You have to take care of your elderly in your families and those who don't understand how these technologies work. But on the other side, if you are a developer, a data engineer, for example, or somebody who's building these systems, the responsibility is on you. You have to protect people, data privacy, or, all these, like, for example, majority of the people don't even know these technologies. So when you're building these things, keep that in mind that these people are your responsibility because you have the power. Data is very, very powerful. You have the power, you have to protect people. Apply encryption, anonymize data, make sure mask it so that nobody can steal it. And even if they steal it, they cannot use it. So that is your job as a data professional. That is your responsibility. Okay. So I think I can just wrap up with that. And let's see if you have any questions that I can answer. Let's see, there's a lot of chat going on. All right, so I will go off.
Yep, and thank you, Professor Ali. Yeah, I saw some questions were coming in, and we can also take some live questions as well. So
Yeah,
feel free. We got about 20 minutes here. You could use the raise your hand feature with
yeah.
Zoom. You can ask a question live. So as people start to muster up the courage, why don't we get started with some of those that were put in the chat? I know there was one about basically it's both a technical and kind of a philosophical question, which is how do you prevent bias? How do you actually, do you get a team in a room and say, tell me what the bias is, or what measures can you take?
Yeah, that's very interesting actually. What you can do is the most important thing to is bias is a risk that can be mitigated. It cannot be completely eliminated, right? So in order to reduce the bias, you need to bring different perspectives. For example, if your use case requires to use people's data, then you should bring different kinds of people who understand different cultures, right? And if it requires you to use sales data, then you need to bring different people who understand their sales data. So the more perspectives you have, the better chances of reducing your bias is there, but you cannot completely eliminate it. It will be there.
Great. And then I see some hands are being raised now.
Yeah,
So
call them.
yeah, so let's let Yushi feel free to unmute and ask away.
Oh, hello, Professor. So I have one question. After listening to your slide, I understand that the data engineer, as you understand, is to build some models to analyze the data. And I have a question like we build these models like to help others, like more original people to analyze data. So if I am an engineer, a data engineer, after I building such models, what can I do or what can I do further? Since I think it is possible that after we making the models, everyone, every public know how to analyze data since they can directly use the models. So what else could we do? So what could we make us different than other people who can directly use the models? Is
So
the difference is that we can understand the basic knowledge inside these models.
So your question is that, if you acquire these skills to become an AI specialist, how we are different from other people if they can use the technology, right? Well, I'll just give you a simple example. If you go to ChatGPT, you can use ChatGPT to create code, but can you run it? I don't think so. Many people can copy paste that code, but they run it and it just throws errors, right? So in order to answer your question, the skills that you're acquiring that will always be useful because what, just because you are giving people the ability to analyze data using this model, somebody needs to maintain that model. Somebody needs to retrain that model because there's a concept of model drift. And because of data changes, the model will start drifting and you have to bring it back. So your skills will always be useful. Okay.
Yeah, thanks.
Sure. All right. Lots of hands.
Yes.
Leon.
Professor, thanks for the talk. This has been very interesting and very invigorating. I've kind of been really into AI and machine learning for quite some time. I'm not your atypical coder, right? I kind of learned coding kind of post MBA, post another grad degree. So it's been something that's been a little bit more unique for me. And so I really want to elaborate on the data piece because I've been in quite a few different boardrooms. I've been in lots of positions where I've had discussions with C-suite individuals, and it's all about the data, right? And it's all about what they're being fed. And it kind of brings me to I think there's a CEO of, I believe it's IBM. I forget his first name, but Christian is his last name.
Mhm.
And recently he was the argument that hey, we can save approximately 33 and a third percent on our COGS by laying off X amount of people, which I thought was interesting because it was really based off of an input in this AI platform that they utilized that gave them the output that, hey, you would have these cost savings if you made this move. And it kind of made me think, well, how do you know that data is good data that you're actually going off of before you decide to make such a decision? Whereas in the past, we would actually take that information from a committee perspective, right? You would have sub teams and teams of sub teams that would do all of the work, and we would compile information, and then decisions are made. How do you prevent something like that fully taking hold, especially when you look at a company like Boeing versus a company like Lockheed Martin? Two different philosophies, but what if the machine learning apparatus really takes hold to how Boeing has done things over the last few years? And that's kind of what right looks like. But we know, unfortunately, there's been a lot of tragedies and controversies around Boeing right now. But what if they're learning off of that particular model versus the model that's actually working and that is dependable? Like, how do we prevent that as we move forward?
So your question is that, how do we know which model is correct? And if it is not correct, how do we prevent from it actually becoming commonplace, right? So at the end of the day, models, be it computer models, they also are based on experience, right? And it is very unfortunate to say that, but you know what, once a disaster happens, then they will learn that why we should not have used it. But if you bring data into picture, what you can do is you can run simulations, okay? So even though, let's say, Boeing is using a certain model and it is working for their environment, right? Like I said, it's not a hammer and a nail. Everything is not a nail. Just because it is working in their environment doesn't mean it will work for you. So you can pick up that model and then use your data to train it. And then you will have to extrapolate for maybe next 6 months or a year to see that will it actually perform the way I'm expecting it to perform. So that is one way of preventing it. The other way is, one thing is called A/B testing. What you can do is you can pick a very, very small population, very, very small, so that it is not affecting a lot of people, right? And then you let them play with it. And then at the same time, your other model is running. So you can see A/B testing because you're MBA, so I'm using the A/B testing. So you can see that, okay, B was my model that I got from Boeing, but you know what? The outcome is not as good as I was expecting. Now, it was affecting a very small portion of people, right? So you can just discard it, right? But if you see B is really, really good from A, then you can actually implement it. So you really have to be very, very, let's say, good with testing after you train your model.
I appreciate that. Thanks for the feedback.
Sure. All right, let's see. Abdullah, go ahead.
Hi, so I was, thank you first of all for this presentation. I learned a lot.
Sure.
And as a new graduate in industrial engineering with a minor in applied analytics, I've been really interested in the data science roles instead of the data engineering roles. So with your experience, what do you recommend, what industry specifically that use data science do you recommend us to go into to get the most exposure and then be able to like bring those technologies abroad back into like our countries?
Stay in your own field. You are industrial engineer. You have all these machines. IoT is your way to go, or chemical engineer. Yeah. Just use IoTs. You are in a very good industry.
Okay, amazing. Thank you.
Every industry has a case for you, data science and artificial intelligence. Okay.
Amazing.
All right. Wei Yang, go ahead.
Hi, Professor. Thank you for your your insight. Firstly, I got two questions. So I'll ask one by one. So my first question is, how do you see the nowadays development of AI? Because it's getting faster and faster, right? From ChatGPT 2 to 3 to 4. And what do you think? Should we put some limitation on the speed of the AI development? Because I'm kind of worried. So one day, the related area like data engineering or something like that won't feel the need for the AI. So do you think should we put some limitation on AI development?
Okay, so you're speaking of the letter that was signed by a few people last year that they said they just slow down the AI implementation. So the problem here is not artificial intelligence. The problem is our ability to actually adapt. So the technology is moving faster than us. And if you are in a car, I just like, analogies. If you're in a car and that is moving too fast and doesn't have brakes on it, so it is highly likely you'll get into an accident, right? So to answer your question, yes, there should be actually limitation. That's why European Union just recently passed an AI law, right? And then other countries will follow. So yes, there should be a process in place, but limitation doesn't mean you just completely stop the.
Yeah, I got you. And my second question is a little bit kind of unrelated, but I still want to ask. So I've learned a theory about it's called integrate information. So you've been taught that the AI, right, artificial intelligence. So for now, like ChatGPT, they do have intelligence, but as you say, we are not talking like people. They don't have consciousness. So the theories say that if we gather enough information, like integrate that enough information, like there's a lot of information we integrated, they will like generate consciousness. So I want to ask how your like insight on the theory.
Okay, which series is it? Is it
So it's integrated information theory.
integrate information? Okay, well, I don't think a machine can, create conscious. It's just, I don't think that's possible, but yeah, it will become very, very smart. With the more people use it, again, like the way we drive cars, artificial intelligence will become part of our life, the way we use our phones. The only thing it will do is it will become smarter and smarter. I don't think it can create life on its own, not in my opinion.
To piggy off of that real quick though, Professor Lee, just because the question popped in my head and we'll get to the other, but something about guardrails, right?
Yeah.
With these AI, I think there could be a case to be asked about how do we ensure that, we don't specifically tell an AI it can't do something. And so then it does and it goes and we said, well, wait a second, a very silly example, but hey, we want to reduce fraud in the banking system. And we don't put in the protection of, but that doesn't mean you just shut down the banking, the digital banking system, right? Because the AI figures out, well, that's the easiest way to prevent fraud is to just shut the system down.
Exactly.
What are the guardrails and how is the industry protecting against things like that?
So EU just passed the law. It's very comprehensive, just like they had done the GDPR for data privacy. So their law and our president here in America also passed a law. I mean, I don't have to go into the details, but the laws are there in place, and then they are there as guardrails. And to answer your question, yeah, you're right. So like in the society, we have bad actors, right? We have criminals out there. And for that, we have police, right? So similarly, in the future, I don't know when, 3 years, 5 years down the road, the same way we have, if there is rogue AI and that is doing something, that we will have actually agents that are going to go and stop them. We will have the good AI as well. So that's how I think about this whole system, like the AI police.
Thank you.
Sure. All right, so let's see. June.
Hello, my name is Jun Young Moon. I'm currently working at venture capital in the other side of the world, which is Korea. And I'm really thank you for the wonderful presentation. And I have two questions. One is, how can I've seen the broad landscape of new service that's arising by the AI development. How can the company can differentiate in their service to the other existing AI service in the world? And another thing is, what kind of techniques should I prepare for the rise of the AI in the future, for example, for 5 years?
So the techniques in terms of if a company wants to adopt AI or they want to evaluate AI, what is the question?
Pardon?
If they want to adopt AI, what techniques they should build? That was the question.
What I was saying is that how can the companies can differentiate their own products to the other existing
Right.
AI services in the world?
Yeah, right. So what happens is that, research is always the way to go, right? You can do your research and see what is already available in the market and then find a problem that nobody is thinking about and then find a solution for it. That is one way of differentiating. So now that problem can be very silly problem. I mean, look at like Grammarly, we already had Microsoft Word and we already had Google Docs and everything, but Grammarly comes out and then people are using it and then find a problem that people really are worried about. And then that is how you can differentiate yourself. And in terms of you, for example, somebody like you who's in venture capital, somebody like you can utilize artificial intelligence to automate a lot of analysis of these companies. All these companies are coming, you can pick up their data. Let's say if they have been in business for 2 or 3 years, take all their financial data and analyze, are they healthy? Are they not healthy? Are they going to go down? Are they going to go up? So you can use artificial intelligence there. But when it comes to decision making, as we discussed earlier, decision making is actually two-step process. One is data driven. The second is your intuition, right? So do not depend on machines completely. You have to use your intuition as well.
Thank you very much.
Sure. All right, we have Gavin.
Hello. Thank you for your insights, Professor. So I have two questions. One's based off the other. So the first question is, so do you think in the near future, within 5 to 10 years, we'll see those like recursive LLMs, let's say, that basically recursively does feature engineering, data cleaning, all that to retrain itself or fine-tune itself in a sense, without the need for human intervention, and it just recursively improves upon that. And do you think, and the second question is basically, are we going, perhaps like, what if the neural net approach is has flaws, like human neurons, right? It's like three-dimensional, but computers can only simulate two-dimensional tensors, and computers are discrete, where human neurons are probably continuous in some ways with the signals. So do you think that could be the fundamental architectures could be improved in the next 5 to 10 years?
Well, I don't know, the technology is moving so fast, but when the quantum computing comes out, it will make it a lot easier. Right now, it's just a concept, right? Very,
Right.
very. So quantum computing will resolve the neurons thing you're discussing about. And the other thing was that, you know what if there is a problem with your neural network or thing? So yes, your models will have problem. Like we talked about that, you know what, there will be a drift and you will go and fix it. And then automation, yes, even now it is happening. Reinforcement learning is what you're talking about. That is what is
Right.
happening now. And then I think I read a week or two ago where there is one of the, I forgot the name of the machine, but basically it can write code. So what is happening here? You have access to your Microsoft, you have access to GitHub that has hundreds of thousands of developers. All the code is there. So what is the machine doing? It is just like a human being. You can read 100 books and you can learn anything, right? A machine can read 100 books in a day. That's what is happening. So when you talk about automating code writing or feature engineering, it is possible. It can happen, but a human will always be involved. Human in the loop will be there because you are guiding the machine. I mean, it can be autonomous, but you are guiding it. I think human beings will always be involved in artificial intelligence.
Thank you.
Okay. And we have one last Abhay.
Hi, Professor. Yeah, I'm actually a recent computer engineering graduate from the University of Illinois, Urbana-Champaign, so quite close to UChicago. So I just had like two questions mainly. So you mentioned just now that ChatGPT and other AI such models, like you ask them for code and the solutions never actually work. What approaches would have to be taken to build models that actually build working solutions eventually?
Going back to the data. So the more working solutions you feed into it, the
Yeah.
more working solutions it can create. It is generative AI, it's generating, right?
Yeah, okay.
So if you are feeding it, if I throw in some garbage code, it is going to create garbage code, right? So a machine is powerful. It's a beautiful machine, ChatGPT or any other machine, but at the end of the day, it's data. So bring more useful software, enter into ChatGPT, and then it will generate useful code for you.
So how long would that actually take for it to be feasibly used on an industrial, scale?
You can do it today. You don't have to. Yeah.
I see. Okay.
Yeah. The machine is there. You just need the data.
Okay. Is that much data like available so far?
Yeah, GitHub, Microsoft.
I mean, yeah, okay.
Yeah.
Right.
Why do you think Satya keeps saying that, hey, we have increased our software engineers efficiency by 20 or 30%? That's what's happening. They're reading from GitHub, code is generated automatically, and a software engineer like you is looking at it and then making sure it runs.
Okay. Yeah. Well, yeah, that makes sense. Thank you. Just one last question. I saw that you're actually the instructor of the data engineering course at the UChicago. I was just wondering, like, with the tech scene and the data scene constantly changing, what skills would you say what skills and experiences would you say we should get from our UChicago education?
I think our master's program is really very comprehensive. One, it is, let's say, deep in the theory and the foundations, so you learn those skills, and then we constantly evolve with the trends. So our courses constantly change and bring new technologies. In my opinion, you should just focus on the foundations like stats, maths, and foundation principles. How do you design these pipelines? And use the technology just as a tool, because today you're using one technology, tomorrow there will be another one.
Yeah. Okay. So apart from the courses, are there any specific experiences we should definitely, look for?
Work in the industry. Yeah.
Yeah.
The
Okay.
more you work, the more real life use cases you will come across.
Okay, I see. Yeah, well, that makes sense. Thank you for your insightful presentation. So,
Sure.
yeah.
Any other questions? We are actually 1 minute past. Daniel, what do you think?
Yeah. No, this was great. Professor Lee, thank you so much. And I loved seeing all of the questions were just great today. It was a very lively group. And this is what we want to get out of these sessions. You know, we like to make them as interactive as possible. Feel free to look up Professor Ali on LinkedIn. I know he's very active on LinkedIn. And if you have any questions, I don't know if I should have said that. Now you're probably going to get a lot of questions.
It's okay. Reach out to me with questions.
I put my foot in my mouth. Oh well.
Late, already did it.
Yeah, I already
You
did
already did it?
Too late.
Okay.
Too late.
Too late.
But feel free to reach out to our team if you're interested about the program, about data science in general at UChicago. And we'll be having more of these sessions in the future as well. We will kind of start to I'd probably take a break over the summer. In higher ed, people go completely MIA over the summer. So but we're really enjoying these. And and that was the last thing I was going to say. Feel free to email our team the admissions if there's certain topics you'd like to hear discussed. Right now we're kind of leaving it open to the discretion of professors because we want them to talk about things that they're extremely passionate about. But we'd love to get your feedback. What could make these sessions even better? Because we definitely will be doing more of these in the future. So thank you everyone for joining. Thank you, Professor, and look forward to the next one.
Thank you so much, everybody. Have a good night. Take care.
Bye.
Bye.